Shall we start, sir?
Yes, sir. Yes, sir. We can start.
Yeah. Good evening to all the respected academicians, our honored speaker, distinguished faculty members, and enthusiastic participants joining us from various parts of the world. It is a pleasure to welcome you all on behalf of MEASI Institute of Information Technology to today's session of the Day 4 Online International Faculty Development Program on Emerging Frontiers in Generative AI and Deep Learning from Vision to Language. We are delighted to have each one of you with us as we continue our journey of learning and academic enrichment. To commence this session on a peaceful and reverent note, I request Mr. A.K. Muhammad Gauss, Assistant Professor, to present the Kirat and offer his spiritual recitation. Over to you, sir.
Yes, sir. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم قل يا أيها الكافرون لا أعبد ما تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم دينكم ولي دين بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد صدق الله العظيم. Thank you, sir.
Thank you, sir, for the serene and uplifting recitation. Now, to extend a warm greeting to all gathered here and to introduce today's esteemed resource person, Dr. U. Arul, I invite Ms. N. Saista, Assistant Professor, to deliver the welcome address and provide an overview of our distinguished speaker. Please proceed, ma'am.
Assalamu alaikum and very good evening to everyone present here. On behalf of MEASI Institute of Information Technology, I warmly welcome you all to the 4th day of 5-day faculty development program. Over the past 3 days, we have gained valuable insights from our expert session, and your active participation has truly enriched this learning journey. As we continue to explore advanced and emerging technologies, it gives me great pleasure to introduce today's distinguished resource person, Dr. Arul, Professor in Department of Applied Machine Learning, Institute of Computer Science and Engineering at SciMaths Engineering, that's Savita Institute of Medical and Technical Sciences, Chennai. Dr. Arul holds his bachelor's and master's degree in computer science and engineering and completed his PhD from Anna University in 2019 with research focused on optimized and automated semantic web service composition. With an impressive 23 years of teaching experience and a year of industry exposure, he has served in various academic leadership roles across reputed engineering institutions. His research interests includes service-oriented architecture, machine learning, deep learning, cloud computing, IoT, and web service composition. He has published over 25 SCR Scopus interjournal papers and more than 20 international conference papers presented through IEEE and Springer. Dr. Arul is also an innovator with multiple patents, including AI-driven IoT smart shopping system, UK design patent in smart farming drones, solar dryer systems, and AI-based agricultural monitoring devices. His excellence has been recognized with several prestigious awards, such as Best Faculty Award 24 and 25, Best Teaching and Research Excellence Award 2023, and the Preeminent Research Award in 2022. We are truly honored to have such an experienced academician researcher with us today. I once again welcome all the participants. Thank you. And with great pleasure, I now hand over the session to you, sir.
Thank you, madam. Thank you for your warm introduction about me.
Thank you, sir.
So first of all, I would like to, so is my voice audible, madam?
Yes, sir.
Is
Yes, sir.
audible?
Yes, sir.
So first of all, I would like to thank to the management of MEASI Institute of Technology for conducting the 5-day faculty development program and emerging technologies of machine learning and deep learning. Also, I would like to thank the organizers, various organizers of this faculty development program. And also I would like to thank Dr. Vijayalakshmi Madam for given opportunity to share my knowledge in this 5-day faculty development program. And also I would like to thank all the participants who joined for this today faculty development program. I am sure that they will gain some important knowledge of the knowledge and research potential in this today's session. Specifically, they can learn some inputs for how to do the research using the deep learning algorithms. Okay, with this short introduction, I would like to start the today's faculty development program on the topic unlocking the research potential of the deep learning algorithms. Shall I confirm that my PPT screen is visible for every
Yes, sir.
participant?
Need to slideshow, sir.
Yes, sir. Okay, thank you, sir. So first of all, we want to know about that what is the research focus. So research focus on the deep learning. There are the wide range of algorithms are there. So in this session, what I have planned is I want to first introduce that very primary algorithms in the deep learning, how they can be used potentially for the research. And then we move to that the advanced level of algorithms, using that how to we do it research. So the deep learning research, it starts from the artificial intelligence, machine learning. So it is the evolution of the deep learning. So the deep learning, it is available to our research in the recent 2 decades only. So before that, we had the artificial intelligence initially. From that artificial intelligence, the machine learning is evolved. Then after that only we had the deep learning algorithms. So first we would like to know that what is the artificial intelligence. Actually, the artificial intelligence, it is the process of making the computers to think like the humans. So first the artificial intelligence term coined by the Alan during 1950, during the winter session of the conference. And he tested that some research focus, like how to make the computers can act like the humans. For that he used that, he developed that computer algorithm. That computer algorithms are run in that particular machine. And other side, there are the some interrogator set, they asked the questions. And the interrogator as very naive user, he doesn't know, he didn't know where he was connected. But the computer is brilliantly answers for all the questions. During that time, that is the first test and conducted, and it was a pass. Actually, totally it was pass, and it demonstrated that the first evolution and first movement towards that machine can think and it can act like the humans. The next after that, the machine learning. The machine learning has it is a part of the artificial intelligence that can learn by through the labeled data, and also by experience it can learn by itself. That is called that unsupervised learning. And so after that we had that deep learning. So deep learning, which used to evaluate or which is used to overcome some of the problems in that machine learning. So machine learning, it is used to handle that very small amount of data. and we want to make that machine to process a very large amount of data, or because nowadays we are using that very millions and trillions of data, such a vast kind of data we want to process, then we need that deep learning. So deep learning, it is primarily evolved from the imitation of or mimic from the human brain. Actually, here you can see that so artificial intelligence, it is enclosed that machine learning, and machine learning it enclosed that deep learning. It is and the deep learning, it uses there are several techniques from that artificial intelligence and machine learning. The foundation is the artificial intelligence. From it takes that inputs, and also it uses the machine learning algorithms. Then it implement the complex processing, how to make the learning, how to make the computers learn by itself. So the input to the deep learning, it takes from that artificial intelligence as well as from the machine learning algorithms. So also I would like to share what are the types of machine learning algorithms. Since the deep learning algorithms are evolved from that machine learning, so it is you need to know. So all the participants need to know that what are the types of machine learning algorithms. So supervised learning algorithm, the supervised learning algorithm where we give the labeled data. So labeled data means the data, it contains a set of information. For example, the data it contains, for example, suppose you want to predict the weather forecast, like the humidity and the climate situation, so etc. etc. It's all the data is there. And we give the labeled data to that machine. Labeled data means every feature it has some label, and the machine can find out whether the rain will come out tomorrow or today. Like that, it can make the prediction. That is called that one kind of supervised learning approach, also known as the regression learning. And if the prediction of that particular supervised algorithm based on that future data, and it classify whether it is belongs to the one category and the other data is belongs to another category. It is called the classification. So regression of the supervised learning means it is prolonging over the time. That is called the regression. The classification means for given input data, it classifies whether it is present or not present, or whether it is available or not available. Like that, it classifies. It is called the supervised learning algorithm. On the other hand, we have the unsupervised learning algorithm. So unsupervised learning algorithm in which
அது தெரியாது. அல்ல இப்ப ஆஃப்னா என்ன ஆஃப்னா என்னது எதுனா இங்க கோட் போட்டு வச்சிருக்கிற ஆஃப்னா ஆமா.
So unsupervised learning algorithm, we give the raw data, that is called the unlabeled data. And from the raw data, the machine can analyze the raw data, and usually it does that process of the future extraction. Future extraction, nothing but from the raw data, it analyzes data and find out what is the information is there. That is called the pattern recognition. And after that, it classifies it clustering the data. Okay, and sometimes it can do that. It can apply some rules. Through the rules, it can learn what is available in the data. That is called the unsupervised learning algorithm. And reinforcement learning algorithm, in which the machine, it does not have any data, but it uses that some probability, stochastic marker decision process. By using it, it can gain some rewards. Mostly these reinforcement learning algorithms are used in the robotic and self-driving cars. And usually the reinforcement learning, it learns by itself by using the camera. It can catch the videos through the camera. and then it analyzes that continuous motion pictures. Then it analyzes by itself, and it is doing some set of processes on the images, okay, and sequence, when it makes the decision. That is called the reinforcement. There are the three major types of machine learning. Similarly, the deep learning also, it has the majorly three different types of algorithms are there: supervised learning algorithms, unsupervised learning algorithm, reinforcement learning algorithm. So now we dive into this, what is deep learning. Actually, deep learning, its concept arrived from the neuron. So it is the fundamental concept in the deep learning algorithm. And the neuron, it is the imitation of the human neuron. And the human neuron is a biological neuron. And we imitating that type of implementation of the neuron in the deep learning, that is called the, that forms the neural network. Actually, that neuron here, it is called the node. And these deep learning algorithms that uses the multiple neurons are connected in that layers. And every layer, it is stacked. It is a cascade that multiple layers. So the deep learning in which it uses that the cascading of the multiple layers that are processing that data in the non-linear processing units. So non-linear means not sequential. It is processing the input information, what it received from that input layer, and it processing that non-linear processing for the future extraction. The future extraction, it means that for the raw data, it analyzes the data. It takes as the input that raw data, it analyzes the data, and it finds the some whether it has the useful pattern or not. That is called that future extraction. And suppose the data is noisy, that is also called as that dimension reduction. Dimension reduction, it is a process of removing the noise from that available data. Then it transforms the data into that some useful structure for processing that deep learning. And every successive layer, it uses the output from the previous layer as the input. And these deep learning algorithms, it can be used for both supervised and unsupervised. Also, it can be used in that reinforcement learning. Now, let us see why we need the deep learning algorithm. So we already seen that machine learning algorithm. So the machine learning algorithm, it is capable of learning to make the machine to learn by using the limited data. So limited data means the data is not a big one. Nowadays, we are using the, so day to day, we are using the data that is in gigabytes and more than the gigabytes. And in order to handle that billions of gigabytes of data, we need that we need the deep learning algorithm, because the machine learning algorithms is not good for handling the high dimensional data. So, and also it is difficult to do the feature extraction and object recognition in the very high dimensional data. So this is the primary drawback of the machine learning algorithm. So in order to do it, this in order to avoid this drawback, the next evolution of the machine learning algorithm, that is called the deep learning. So the deep learning algorithms, it has the computationally expensive one. Since the deep learning, it uses that GPU concept. GPU, it is the graphic processing units. It is the GPU units are able to process that billions of data, so that it can, so the deep learning, it has utilizing these GPU units, so it can able to handle that most vast amount of data. And also it is capable of processing the data within the stipulated duration of time. And also these deep learning algorithms are able to do the feature extraction automatically. Now let us see the neuron structure. So this is the single node structure in the deep learning algorithm. And this single node in this single node is called the neuron. And this single node of this neuron, single node is called a neuron. It gets the input. It gets the input, and the inputs are multiplied with that weighted value. Some weighted value it is added to this, and this weighted value usually taken by random function, or by approximation we feed this weighted value, and it is multiplied with that input value. And so the weighted, the sum of the weighted and these weighted values from the different inputs, if you multiply with the different inputs, it is summed up together, that is in the activation function. Sorry, in this node. And in this node, it sum that all the weighted values, and also it is adding that bias. So bias is that constant actually. So this value is the constant value, and the need of adding that constant value along to this summation of the weighted value, since it want to eradicate some of the noise or future dimension reduction. For that we add that bias. Then it produces that the reduction of some information, and it is given to that activation function. So activation function, it plays that very vital role in that neuron. Activation function, it evaluates that what is the input it is received from this summation node, and whether it analyzes that whether it is correct or not, or it is matching to that predicted result. And if it is predicted, it is mapping the input received by the activation function, it is mapped to the output properly. Then it is sent to it pass over to the next node in the neural network. So this is the fundamental operation in the neural network, specifically by using the neurons. Now let us see how does the deep learning works. When we say the term neural network, it is denotes that only one hidden layer. Actually, this yellow color node, that is called the input layer. So this is called the input layer. This is called the input layer. So the input layer, it receives the inputs, and it is multiplied with that weighted values. So the link, it has the weighted values, and it is multiplied. Every input multiplied. Then it is summed up in the node. And this red color nodes are indicating that hidden layer. The hidden layer usually to performing the processing from the weighted input value by adding that bias also. Then it is passed to that output layer. So the output layer which receives that data, it receives the data through the activation function. So without activation function, the data cannot be passed to that output layer. So this is that simple vanilla ANN. Okay, and next we will use the deep learning. The deep learning it has that several hidden layers. It has the several hidden layers, and it has one input layer and one output layer. So all the layers are interconnected, and all the layers are working in the non-linear manner. Non-linearity means the information from that one node in that one hidden layer or any hidden layer, it is passed to the any other nodes in that interconnected manner. The data it usually does not pass in the linear fashion. It is passed in the non-linear fashion. And also if you see the structure of the nodes in the hidden layer, the nodes are stacked. The stacked nodes, stacked structures can be followed. And usually these hidden layers, it processes that raw input data and analyzes the data. Then it performs the future extraction and the mapping. And the given data usually divided into the two categories. One is called the training data. During the training process, deep learning learn by itself, and the remaining 20% of data or whatever the portion is left out in the data, it can be used for the testing purpose. And most commonly, the deep learning, it has the multiple layers of interconnected artificial neurons that are called as the nodes and that are stacked together. And they are processing that given data, and it find some predictions like patterns or what is the hidden in that raw data. The primary types of neural networks, and here we have seen that 4 types of neural networks, like artificial neural network, convolutional neural network, recurrent neural network, and generative adversarial neural network. So these mostly all the types of deep learning algorithms that are called as the supervised deep learning algorithms. You know what is the supervised deep learning algorithm? So supervised deep learning algorithm for which we give the labeled data, and the algorithm is used in these types of neural networks that are monitored continuously, and when there is anything is going to wrong, and it is rectified by using the back propagation method. And the last one, the generative adversarial neural network, that neural network, it can be used for both supervised as well as that unsupervised learning algorithms. Mainly that artificial neural network, it can be used for the classification, regression. Conventional neural network, it is for handling the image classification. Recurrent neural network, which is used to identify some fact information. And mainly the recurrent neural network can be used for the NLP. Natural language processing, text recognition, text processing, for which we can use the recurrent neural networks. Let us see one by one. First, let us explore what is the artificial neural network. So the artificial neural network, it consisting of the input and output layers. Also, it has the hidden layer consisting of the unit that transform the input to the something the output layer can use it. So artificial neural network, as I told you, it can be used for that classification purpose. And the artificial neural network, ANN, it can be uses the technique that is called that feed forward technique. And through the feed forward technique, the input data, what it is received through the input layer of the deep learning, and it is pass over to that hidden layers. The hidden layer process the information, and it predict that the useful patterns or useful information from the given raw data. And if anything goes wrong, then it do the back propagation. So anything is wrong means the actual output generated by this ANN algorithm, it is not mapping or it has some error. So in this case, it back propagate, it moving backward to the previous layer of that algorithm from the output layer, and it try to resolve that error, or it try to reduce that deviation. And also during the this back propagation, it is usually done during the training process, and which allows the network to adjust their hidden layers values, that is the weighted input value. No, that weighted input values are just hidden layers, and it is this process, it takes repeatedly until it can approximately map to that expected outputs. So until that time, in the process can be continually done, and it is the ANN mostly used for finding the patterns, and that finding the pattern is very complex and involves that various human programmer to extract and make the machine to learn. But using this ANN, it can be done in a very easy manner. Now this is that how the ANN it is working, and it is mapped by using that biological structure of the neuron, and this is called the neuron, and the entry it is used to receive the inputs. The entries are that these are that very fine layers which is used to getting that input from that external environments, that is called the entries. Then this the nucleus of that neuron, it process the information, and through the axons the information passes to the other neurons. So the same, so the biological structure of the neuron, it is mapped to the neural network. So that I already told you that the neural network, it is the imitation of that human brain and its neuron connectivity. So already told you that already I explained is this is the input layer. This is the first layer. The input layer, we give that input. That input is that given by using the data set, and the hidden layer it process that information, and the output layer it produces the output, and any deviation in that in the output, so it can be reiterated by using the back propagation techniques in the artificial neural network. The types of ANN, feed forward ANN. So the feed forward ANN, it takes that input under the weighted input multiplied with the weighted value. It is given, it passes in the sequential manner. So see here, the data, it can be processed through a sequential manner. That is called the feed forward sequential manner. Every node, it receives the data in the sequential manner. That is called the feed forward. As well as the data can be passed to all other nodes in the network. This is called the input layer. And mainly these feed forward ANNs can be used for the pattern generation, pattern recognition, and the classification of the data. And the another one is the feedback ANN. The feedback ANN, it can be used for reiterating that network, and it has to use to identify the and rectifies that whatever error, that whatever that output it is not mapped to the predicted value, or it is not giving that expected output. Then it feed forward. This is that this bottom arrow, it is connecting to that nodes, that is called the neurons. That is called the neurons. Okay, and it is receiving the input data, and it passes over to that the hidden layer. This is called the hidden layer, and the hidden layer processes that raw data, And after the processing, through activation function, it pass over to the output layer. In this output layer, if it is not mapping to that expected output, the predicted value not mapping, then it again reiterating to that input layer, adjusting that weight and also the bias. Then it again it is doing, and this process is repeatedly iterating until it is getting that output somewhat mapping to that. Somewhat it is mapping to that the current input. So activation functions and its types in the that are types used in the deep learning algorithms. So actually, the activation function mainly used for getting the output in that neural network node, and also it is known as the transfer function. And as I already told you, already said, it is used to convert the input signal of the node to the output signal. So it is performing activation function. Usually, it performing the mapping of the input to the output. So once the activation function is evaluating whether it is mapping properly, then only it goes to that output signal. And activation function, it takes that the sum of the products of the inputs and the corresponding outputs, and it apply. Then only we apply that activation function, and to get that output in the output layer. So broadly, the activation functions are classified into two types. One is the linear function, another one is the non-linear activation function. So linear functions means it is the straight line and with the slope. The slope that is called that linear. And usually in the linear function, it takes that minus value to the plus value. So minus infinity to the plus infinity. So linear kind of things. And the non-linear activation functions in this case, it uses that like a curved, and the value it takes from that minus negative value to the positive value. Is the curved, like that is called the non-linear activation function. The types of activation functions and that are non-linear and used in the deep learning algorithms. Sigmoid activation function, and it is mainly used for predicting the probability. The sigmoid activation function, its range usually starts from 0 to 1, because it takes that probability of the value ranging from the 0 to 1. That is called the sigmoid activation function. And next one is the tan H activation function. And the tan H activation function, mainly it is used for the classification of the two classes, and also it can be used for the multi-class classification. The tan H activation function, it is similar to that sigmoid activation function, but it takes that probability of the values, not probability always, it is take the values from the -1 to 1. So the input values range from the -1 to 1, it can be it can be given, and the function tan H activation function, it can able to process that given data. Then next one is that rectified linear unit, shortly called as the ReLU. And most commonly this activation function used in the deep learning. And the major advantage of using this ReLU deep learning of activation function, which eradicate that negative value. So negative value, it is given to this activation function, then immediately it is turned into that 0. Also, we have the another one activation function that is called the softmax activation function. And mainly the softmax activation function, it follow the concept of a sigmoid activation function, which is used for the multi-class classification. So how the back propagation works in that ANN? So majorly the back propagation, it means that the output generated by that neural network, it is not anticipated, and it has some deviation from the what we expected result. The deviation is called that error. When the error is there, then the ANN, it can back propagate to the previous layer and process the data. And again it will be run. And if it is not rectified again, then so again it is run and it goes to that output layer. It is not producing that optimal result. Then it can go back to that prior layer and before the prior layer. Then so like that it will be back propagating that values and adjusting that bias and the weighted values in that every node of that neural network. So this process is iterated until it getting that high accuracy of the outputs. So let us see the step-by-step working logic of the back propagation ANN. It randomly initiates the weights using the random function. And usually that values range from the 0 to 1. And also then it observe that input through that input layer. So each future is given to the one input node. The future means it is that the single input or it has that vector of values, vector of the values. Then it uses the feed forward propagation method. So already we have discussed it. So what is the feed forward network? The feed forward network in which data it can pass in sequential manner from the input layer to the hidden layers. That is, it is forwarding the input data from the left to right. And the neurons are activated through the activation function. When it is impact on that activations, it has the removing the noise. And each node in that ANN, it process that the sequential data and it pass to the next node in that neural network. Next node. The hidden layers, there are the several, there are the more than one hidden layers are there in this ANN. And each hidden layer, it receives that input data in that linear fashion. And also it creates the non-linearity. Non-linearity in the sense that data, it is moving from that one layer of the network nodes to, and it move over to the other layer of the network node, that is called the non-linearity. So non-linearity, it is most commonly needed in that ANN, since it want to find out some useful patterns. So the output of that one layer, it is one hidden layer, it is sent to the next hidden layer. Okay, that is called the forward propagation method. Then compare the predicted result to the actual result. So if there is a major deviation, is called the error. When the error is generated and it can be adjusted, error can be adjusted by using the back propagation method. The back propagation method, it pass back that data to the previous layer, previous layer. So until the hidden, all the hidden layers, from that hidden layers, it again process it by adjusting that weighted sum value and the bias value. So this adjustment, it is used to remove the noise or remove the error in the given data. And finally, this back propagation is repeatedly done until the output is mapped or compensated to that expected or predicted outputs. So The step 6, repeat the step of 1 to 5, update the weights in each observation. Finally, if there is a optimal result is obtained, the whole training process is over, and it is output of the training process is passed through the ANN, and the process is called the approach. So the approach, it is nothing but how the ANN, it rectifies the error through the back propagation, and it can be run in that series of the steps, that is called the approach. Now I will demonstrate the feed-forward neural network with the 2 hidden layers. Not demonstrate, I explained that how to design the feed-forward neural network with the 2 layers. So this is the first is the input layer. The input layer, it taking the random value. Every node in the input layer, it taking the random value, or we give the some future of the our data set, and it is multiplied with the some weighted value, and it is so the input layer from which the input layer nodes from which the data can be forwarded to the hidden layer in the non-linear fashion. Non-linear means the data not only passed to that one node in the hidden layer, it is passed to the all nodes in the hidden layer. So it is called the non-linearity. The first hidden layer is called, it is implemented by using the ReLU activation function. So ReLU activation function mainly, which is used to suppressing that negative values. That is called the hidden layer 1. Then once it is suppressing the null value or noisy data by using the ReLU layer, the first hidden layer, then it is sent to the next second hidden layer. The second hidden layer, it is activated by using the Sigmoid function. So Sigmoid function, it can be used for mainly the probability, identifying that probability of data, probability pattern from the given data, range from the 0 to 1. Then it is passed to that output layer. So the output layer, it is implemented by using the softmax. Softmax mainly used for the classification. For example, suppose if you want to find out whether the given image is cat or dog, you want to classify. So in this case, we give that a set of numerous set of inputs, numerous set of pictures to this algorithm, then it classify it finally. The error, if the error is present in this feed-forward neural network, it can be eradicated by using the cross entropy. So cross entropy is the method which which is used in the back propagation. And this is how the feed-forward neural network it is working in the ANN. So we give that random input value, and it is stored in like that matrix. And this random input value, it is multiplied with that the hidden layers. It is multiplied with the weighted values. So this is the weighted value. This is our input value we give for our design of the ANN neural network. And this is the weighted value. So weighted value, it is calculated by multiplying this input value to the random value. And this is the output. Actual output is the classification algorithm. So here one means it has the high probability and classifies the particular pattern is belongs to the corresponding category. And similarly, the data is passed to the next layer. And we have the 3 layers. So every layer, it calculates the weight. And this is the matrix representation for the layer 1. So layer 1, we give the input. That input is multiplied with the random weight. Then it is added to the bias. So bias is actually that constant, is the constant value, and mostly which is used to add the additional ingredient to make the to make the prediction is better. So constant, it is actually the constant value bias. So here we have given the input and it is multiplied with the random value. It is ranging from the 0 to 1. Then we add the bias value. On the hidden layer, first layer, it is by using that ReLU operation in the layer 1. So this is that formula of the ReLU 1. ReLU is equal to maximum of 0, x. So that is when the negative value is given, it is automatically converted into that 0. And the value, input value mapped in this hidden layer 1 range from the 0 to 1. If negative value, it is suppressed. This is the main idea of using ReLU. Firstly, ReLU activation function, it removes the noise from the data. Then second layer, matrix operation. So how the first layer in which the first layer output, the first hidden layer output is taken as the input for this second layer, and it is multiplied with the weighted values, and also it is added with the bias. The second layer, after this processing, it will produce some output. That this output is given to the input to the next hidden layer. The next hidden layer, which is the sigmoid activation function. So a sigmoid activation function, it is working like the producing the S-type curve. And third layer, the sigmoid activation function mainly which is used for the probability analysis. And the third layer is that performing the matrix operation. So the third layer, it performing the softmax, that is the classification as per our AN algorithm. So softmax, it classifies the data. So this is that logic of it gets the input from that previous hidden layer, then process the input, then it adds that the bias value. So this is the softmax operation, mainly used for that classification method. Then so all the hidden layers like ReLU, then Sigmoid, then another one is the softmax activation functions are performed. Then it produces that output. It is processed to the output layer. The output layer, it compare that the predicted result to the actual result. And if there is a deviation, that is called the error. Actually, AN is mainly used for the probability reasoning. It analyzes that output, whether it is accurate one, then it accepts the output. Otherwise, it use the back propagation method. So this is that. Here, how the loss is calculated. It uses the logistic loss method by using that normal distribution method. Logistic log, this is the formula. And if the error, it is not, if the output is not mapping to the predicted value, then it is back propagating error. First, it in our example network, first it back propagate from the output layer to the previous hidden layer and adjusting the weights. And by using the derivative of the soft max activation function. Next, and even that the activation function there in the hidden layer 3, it checks that it is suitable or mapping to the output, and it is not mapping. Again, it back propagate from the hidden layer 2 to hidden layer 1. And here it uses the sigmoid activation function, and by using the sigmoid derivative, it calculates. And even the output of that hidden layer 2, it is not suitable, then it back propagate to the hidden layer 1, and it back propagate to the input, adjusting. So that it means that adjusting that input also. So the input is very noisy. The input should be adjusted further, so that it is suitable for processing. So finally, that outputs are updated, and again the forward that over the hidden layers, then recalculates the errors, and it find out there is a mapping between that actual output, and even if it has the deviation after adjusting that weights and bias and the input values, then it back pass and find out that errors, and this process repeatedly until it gets the some mapping, until it gets that optimal outputs. Mainly these deep learning algorithms are focused on getting that output in the very accurate manner. So accuracy means that suppose that you have, for example, CNN algorithm. CNN is produce the output is the 80%. So next time the same algorithm, it has to use the very huge volume of data, and it has to find that even more accurate one, 87%. It has to find out some improvement in that algorithm. That is the major focus of the every deep learning algorithms. And also the deep learning algorithms are able to handle the vast amount of data, very large amount of the data, since it uses that GPU unit, graphical processing unit. The graphical processing units are able to process that huge amount of data like the supercomputers. And this is now we see that one example application, that is a churn modeling problem, and the churn modeling problem, which is focus on identifying that individual customer will leave the bank or stay in the bank based on the geodemographical information and the transactional information. And this problem can be solved by using the ANN, by using the probabilistic approach. So probabilistic approach means if the probability of the output value is greater than, okay, the output is greater than 0.5, then it is accepted. Less than 0.5, so it has the deviation in the accuracy, then it has to use that back propagation. And this is that the given data. And this application is created, churn modeling application or churn modeling problem is implemented in Python. First, we have to import that necessary libraries, like we have to import NumPy, use for which is NumPy, it is used for the numerical Python, which is used to store the matrix array, processing the matrix, and import the pandas. The pandas, which is used to handle that kernel-like data, grid-like data. So we want to process it, then we have to use the pandas. Then we have to import that matplotlib to explorate the pictures, graphical images you want to draw. Then you have to import it. Then import the data set. We can import the data set by using the Python statement pd.read underscore CSV. In the name of the file, we have to argument as the input. And we take that this is that x and the y value, and the y value is that dependent value. Y value is the dependent value, and the x value is the independent value. So independent values we take from that our input data from the futures 3 to 13, and the output is the 13. So if you see the graph, you can understand this is that input value. We take it from the customer credit score, geography information, gender, age, balance, etc. till 12. Then if the customer exited, that is the output. That is the column 13. So encoding the categorical data, because without analyzing the encoding, it is nothing but analyzing that data. Without analyzing data, we can't fit into this ANN model. So we have to encode data. For that, we use that label encoder. Label encoder and one-dot encoder. These are the two encoders we are using. So label encoder, it is analyzing the data. One-dot encoder, it is try to transform the data into the array. Then once this encoding categorical data is over, then split the data set for the test and the training. For that, we can use that size-kit lane model. And here we do that splitting of data. 20% of 80% of data it can be used during the training process, and 20% of data it can be used for the testing process. And one of the important things we have to do it in that ANN based implementation of the churn modeling problem, that is called the future scaling. So future scaling, it is the process of avoiding the data is overfitting or underfitting. So overfitting means the data it is too randomness, or it is not fitting within that range. Then we have to normalize the data. So normalization, we use the two different techniques. One is the standardization, and one is the normalization. So standardization, it is the standardization which is making the data its mean value is equivalent to 0, so that it makes the mean value is equivalent to 0. That means the it standardizes the data. That is called the standardization process, and standard deviation is actually 1. And this normalization process in which it find the range of data, it analyzes the data and make it converts into the range from the mean value to the maximum value, mean to maximum value. It is called normalization process, and this is the Python code for transform the data using the normalization. And next we build the artificial neural network by using the sequential model, and the output model is the dense spaced. Dense spaced means the output of all the hidden layers are accumulated in that single output layer, that is called a dense layer. In the classifier, we use the sequential classifier. And adding the next step, we have to add that input layer to the first hidden layer. And the first hidden layer, its activation function is ReLU. And adding the data to the next hidden layer. So for that, we use that dense function. So because we are passing over that input of the first hidden layer to the second hidden layer. The second hidden layer, it is implemented by using the activation function Sigmoid. And finally, we are compiling our code by using that optimizer that is called the Adam optimizer. So Adam optimizer, which is usually performing that classification. So in this churn modeling application, using that AI, it find the customer can stay in the bank or leave the bank. So that is our major objective. So we use that classification. And finally, we want to make the accuracy. So accuracy, it can be calculated based on that confusion matrix. The confusion matrix depicts that the performance of that algorithm. So fitting that ANN, we are fitting the ANN and initiating that training and the testing in batches, and the batch size is 10. It takes that 10 future values, and the number of iterations we are using that 100. So maximum number of times in the data it can be analyzed through the 100 iterations. And finally, it predict that the result is set. The probability is more than 0.5. The customer leave the bank. Otherwise, the customer don't leave the bank. And finally, it produces that output accuracy. Also, it generates the confusion matrix. This is that Python code to show that output, and the output here is 84, so more than 80%. It is the accuracy. It is the more optimal outputs. Next, let us see an overview of that convolutional neural network. The convolutional neural network, it is the advanced of the ANN. And here, this convolutional neural network, it uses the convolutional and the polling layers. So the convolutional layer, which is uses the stacked future extraction method, and the polling layer, which is used to stacking that output values. And here in this diagram, you can see that the input is given as the parse, and mainly the convolutional neural network, it is used for that categorizing that given category set of images, it is belongs to the particular category or not. So it uses the edge detection, or it uses the method that is called the convertex identification method. And the input images set of that is the 1,000 images or whatever the image is available, it is given as the input, and it is sent to the next layer that is called the convolutional layer. There are a set of convolutional layers out there that are stacked, and this way of stacking and analyzing the data. By the way, we are the polling it to do the future extraction that is called the training process, and it usually performed during the training. And so every time the convolutional layer which uses the slide over the matrix of data. Actually, every image is given, input image given. It can be represented as the matrix. It contains the zeros of ones, and it uses the small slide that slide it put over that matrix and find out that future map. And usually the slide it scroll across that all over the matrix, and it find out some transformation, and it is sent to the next hidden layer. So likewise, it is processing that all over data and identifying that useful patterns available in that set of images, and also it performing the polling and classification of the images during the training process. Then after polling, then it performing the flattening that layer. The flattening layer, it is converting that the final output of that polling during the future extraction. It is transformed into the vector format. That is a single layer of data. Then it is passed over to the output of the flattened layer data. It is passed over to the fully connected neural network. So fully connected neural network in the means that there is a connection. There are the connection from that every hidden layer to the other hidden layer, and it is propagating the data in the non-linear manner. That is called the fully connected layer network. And this fully connected layer network, it analyzes the final output from the hidden flattened layer, and it classifies the data. So it performing the category. There is several kinds of images of the different animals are given. Then the fully connected layer analyzes the data. Finally, it gives that output. So which probability is high in that output layer? Then the particular thing is classified, and the particular image is the zebra. So the output is should be greater than the 0.05. Then it is categorizes, it determines. So other values are 0.2, 0.1. That is not corresponding to the given image. And how it is working the convolutional neural network by using the edge detection. It analyzes that all the edges of the given image, and it find the useful patterns, and it performing the clustering and mapping. Here here you can find that this is the input image. It's a cat. This is the input image, and here it performing the sliding. So this is called the small window. The small window, it captures the data from this picture, and it is converted into the matrix. So the computer usually see what is the value in that in this region. Okay, so that is called that future extraction here. Future extraction. That is called the future extraction. Okay, and this sliding process it can be performed over that all the image. That is called that future mapping, and also called as the kernel. So as already discussed, that input image is processed by the CNN algorithm. Finally, we have the classification. Mainly that CNN algorithm can be used for the medical diagnosis, like brain tumor detection, cancer detection, like that processes. Mainly it can be accustomed to use, and it is producing that more accurate value. The structure of the convolutional neural network, first it performs the convolution, that is sliding operation, then performing that identifying the that are performing that max pooling, then finally flattening. Flattening, it is nothing but converting that final output into the vector. Then fully connected, pass over to the fully connection network, fully connected neural network layer, then it perform that process. So the convolution, it preserves that the facial relationship between the pixels. The facial relationship between the pixels means there is some color value using that RGB value, and it has some edge. These are the things are analyzed by using the RGB pixels. And the slide, it is nothing but the kernel, and it can be move over the entire image. And by the way, moving, it is finding the different future maps. the slide, it is moving to the over the picture, and this is called the convolutional operation. And the stride, it is nothing but the number of pixels through the slide. Okay. So suppose the stride size is very small, then it takes that number of times it find out, it maximizes that number of times it find the futures. Zero padding, this is one of the techniques used in the convolutional neural network, which is used for the edge detection method, and it is usually suppressing that zeros. The input matrix with zeros around the border. So the zero padding process, it apply the filter the bordering elements and eliminate that it identifies the edges. Next, ReLU layer. So rectified linear unit, it is a non-linear operation, and it replaces that negative pixel values and it mapped to the zero. So ReLU mainly used for processing removing the noisy information. The maximum pooling, it is one of the important technique which is used in the dimension reduction in the future map, and retain the important information, whatever the unwanted information from that given image, noisy information, unwanted information, it can be removed off. And users, it employs the three major techniques. One is called the max pooling, another one is called the average, and the third one is called the sum. So max pooling, it is nothing but it takes the largest element from the future map. And average pooling, it takes the average of elements from the future window or a kernel. And sum pooling, it is some of the elements from the window. So flattening, it is the process of converting the pooled future map into flattening and converting this value into the vector. The flattening process, it produces the final output. So this diagram also, this slide also, it shows that the same. The flattening, it is the input to the ANN. And if you want to more accuracy in the CNN is connected with that the ANN algorithm also. And the ANN, which is mainly used for doing the backpropagation method. And finally, the output is sent to the traditional, the fully connected network. Usually, the fully connected network also called as the traditional multi-layer perceptron. So multi-layer perceptron, it is that fundamental units in that neural network. It has the multiple hidden layers, and so every layer it can be processed by using the some activation functions. And final output layer, it can be processed by using the softmax activation function. And finally, through the fully connected network, the output is analyzed, and if there is a deviation, again it can be back propagation. It can be trained by using backpropagation to identify the useful patterns from the raw data. And this is the typical diagram. It shows you how the sliding it works, and every sliding it identifies the some. It analyzes that pixels in this matrix, and it try to identify some edges from the image. The edges in the image, then it performing the padding operation. And so by the way, it can identify that the particular shape from the image. It is called the future extraction. the overall process of the convolutional neural network. So first we have to initialize that all the filters and parameters into the random value. So random value, or we give that some of the live raw data is there, we can give it. Okay. Then we take that input as that images, and we forward. We do that forward propagation method, and it pass over the convolutional neural network and the polling operations. And when it is passed through that the particular polling layer, then it calculates that error. So the error, it is nothing but any deviation, and it can be it can be calculated by using the probability. Also, it summed up that all the errors, and while during the back propagation, it rectifies the error. So the fourth step, it calculates the back propagation. It calculates the gradient descent. So gradient descent, it is nothing but there is a deviation. Deviation, what it try to identify the pattern from the actual image deviation. Then it adjusts the weight. Adjust the weight by improving the errors or to rectify the errors. And this process will be repeated till it identifies the recognized pattern. And once this training set is completed, then it is given the output of the training, it is given to the fully connected neural network for analysis. The practical implementation of CNN, that is image recognition and image classification for the set of 10,000 images of cat and dog. Okay. And in order to do this CNN model, we have to use the sequential model, which is used for initializing our model, and the conventional 2D package, which is used to making the CNN with the conventional step and to add the conventional layers. For the implementation, for implementing the CNN, we use the Keras. It is the framework mainly used for the CNN algorithms. So this is the initialization of our classifier. We are performing max polling using the Python coding, and also we are doing the flattening and pass over the data to the fully connected layer. And finally, we compiling the CNN, then it performs the image processing. And classification of the training set and testing set. So every deep learning algorithms, it classifies the data set as the training set. 80% is the training, and 20% it can be utilized for the testing. And finally, it performs then fit the data into CNN model, and so number of times the approaches then should be given max. So maximum it will be. So each approach it takes that 8,000 steps. So you can analyze that. It is the amazing one, since so every step it analyzes that the future matrix, and it performing that particular pattern recognition process. So finally, it performing the identifying that future extraction from the given image. Then finally, the output it is given to the prediction model. It identifies that is the fully connected layer we are giving. Then it identifies the given image is the cat or dog. Okay. So far we have seen that the ANN and the CNN, the accuracy, if you compare that two algorithms, ANN, CNN gives that better accuracy, since it uses the fully connected network. The fully connected network, it is able to process that very large amount of data, and the prediction is more accurate one. The next primary and supervised machine learning algorithm is called the recurrent neural network. The recurrent neural network, it is usually processing the sequential data, and also it has the internal memory to recall that past information. So mainly the analogy of the recurrent neural network, it wants to performing that analysis of the previous input with the past previous input with the past output. So it has to analyze why it is doing like that, means it try to find out that or it try to rectify the error. Majorly, this recurrent neural network, it is used to process the sequential data, such as the time series or text information or speech processing, such as speech synthesis used in that natural language processing NLP. So for that process, it has to identify the what is the partial relationship between the text and the time series. So that recurrent neural network, it has to use the internal memory, and internal memory, it stores that data for the every stage. The functionality very similar to the ANN. It uses that feed forward method, and it passes the data to that from the input layer to the hidden layer and process it. The major drawback of that recurrent neural network, it is affected by the vanishing gradient. Vanishing gradient means during the training process, the recurrent neural network algorithm is struggle. The input is not, it is not receiving. So the input is not receiving constantly over the time, then it is not able to perform in the training process. So it is the major drawback of the recurrent neural network. And this is the working principles of the recurrent neural network. The recurrent neural network, it takes that input and it is passed to the hidden layer. In hidden layer, process information, and if it is not producing that expected output, again it is processing the data until the hidden layer produces that optimal output. Then after that, through the activation function, it goes to the output mode. Sorry, a minute. So the RNN have the memory that stores information for doing the calculations. Also, it uses that uses the same set of layers for the input as well as producing that outputs. The main features of the RNN are internal memory. It has to remember that past inputs. Also, it has to use the context for processing the any new information. So by the way, it is comparing that the input and output that are mapping properly or not, and uses that sequential processing, feed network. Since it analyzes that in the speech, in the natural language processing, and it analyzing that context of that information, so that it has to use the sequential processing only. The contextual understanding is very important. For example, the sky is blue. The sky is blue is the sentence. In this sentence, suppose we have given the sky only. Then using the sky, the particular word, it can analyze the all possible outcomes. The sky is blue, like that. Other sentences can be formed, but the most outcomes are ending to the sky. It takes all the outcomes and it wants to predict that the actual output. So the contextual understanding is very important, since it has to analyze and find the mapping words for the input word. Also, it performing the dynamic processing. Continuously it updates the internal memory. So whenever that particular hidden layer it performing some processing, then it is continually doing that process until it adopt that or finding that useful patterns in the sequence. So the RNN, it has that input layer, hidden layer, activation function, output layer, and recurrent connection. Recurrent connection means it is moving back to that previous nodes, and it is enabling or adjusting the values in the hidden layers. And it is working by using the time-stamped series manner. Time-stamped series manner, in the case that the value calculated in the particular hidden layer, it is passed to the next hidden layer until that it produces the optimal output. And every hidden layer, it has its own activation functions, and it is determining every hidden layer, determining whether the activation function is able to pass the output to the next layer when it is maximizing that output. Otherwise, it can repeatedly doing that analysis in the set of weights, adjusting the weights across all the steps. So there are the two types of recurrent neural networks. One is that feed-forward neural network. Another one is the recurrent neural network. And the feed-forward neural network, it is simple AN algorithm, and the recurrent neural network is the RN algorithm. So this comparison, it tells us that what is the primary distinction between the ANN and the RNN. So RNN, it uses the loop that prolonging over the time with the memory, and it can able to remember. Okay, and the input can be flow sequentially, and the information can be unfolded across that several hidden layers by using the timestamp. So, and the techniques used in the recurrent neural network is called that back propagation through the time. And here you can see that how the data, it can be propagated and processed from the one node to another node over the time by using the PTT. So the major issues in that RN algorithm, exploding the gradient and the vanishing the gradient. Exploding the gradient means there is a steep, narrow curve during the, it can occur during the learning process. It is called the explosion. That means that there is a high deviation of data. So the algorithm, it takes that, the algorithm generates that very large data, and it is deviating or unfitting. So overfitting is occurs, then it is called that exploding the gradient. And the vanishing gradient means that algorithm is not getting that large volume of data, large volume of raw data, and it is getting the very small data. Then it is called the vanishing gradient. So the vanishing gradient, it can be, this problem can be solved by the LSTM concept. The major advantage of this RNN, it is handling the sequential data. And mainly it is used for the NLP process, natural language processing, text processing, speech synthesis, and the time series analysis. And the major drawback of this RNN, it is computationally slower than the other neural network architectures. That is the major drawback. Also, it can be degraded by the gradient problem. The next important deep learning model is called the generative adversarial network. The generative adversarial network, it is working in the two directions. One is the generator network. It creates that fake data from the original data. And while the other network is called the discriminator network, it tries to find the distinction between the fake data and the real data. Mainly, these adversarial neural networks, it is used to find the detection of the spam mail detection, and also fake videos, fake images. If we want to detect it, we can use the GAN model, GAN deep learning network. How the GAN works? So generator, it generates the fake image, and the fake image, it is imitation of the original image, and it contains some unwanted data or noise data. Then it is given as the input to the discriminator. The discriminator evaluates the data and it compare that fake data with the real data and it try to distinguish the data. And based on the discriminator output, the generator adjust and improves the fake data. And by repeating the process, then the fake data, it is almost trained and it is adjusted and it is mapped to that output. This is also the one of the more clear picture. It depicts that how the GAN works. It finally to fine tune that all the training process and find the GAN is correct. Actually, this diagram, it shows the conditional based GAN method. So conditional based GAN method in which it uses that some of these rules using the condition, it evaluates and fine tune the fake image, and it should be finally mapped to the original image. So architecture of DNN is architecture of the GAN is already analyzed. There are the two models, generator model and the distributed model. Already analyzed it, so no need to analyze again. And it uses it find the deviation by using the minimax loss function. And the generator model, it is producing that fake image, and the discriminator model, it is trying to find out that what is the deviation. And the discriminator model, it is used to maximize that accuracy. And so it is called, this function is called the minimax loss function. The types of GNN, there are several types of GNN. Vanilla GAN, it is the simplest GAN. It contains that generator and descriptor, and it is built using the multi-layer perceptrons. And the major drawback of the typical very fundamental GAN, it produces the unstable training. So conditional GAN, it is one of the advancement of the GAN model. It is working by using the conditional variable, and the conditional variable fed into the both the generator and the discriminator. So finally, the generator, it ensures that discriminator it is given, it is generating that the predicted value mapping to that condition. The deep convolutional GNN, it can be mainly used for the image processings. And we used to generate that high quality and realistic images from the FAC images. Major applications of that JN, it can be used for image generation. If you can generate the new images from the FAC images and imitating as the original image, and super resolution, you want to make the images and the videos are more resolution, then we can use the GAN. And image augmentation, text to image conversion purposes, we can use these GAN models. Now we delve into that, the research focus of the deep learning. So the major usage of the deep learning is we want to do that very raw data, and the data volume is very large, and we had the more computational power, then we can use the deep learning methods. And previously we have discussed about the several supervised learning algorithms. The supervised learning algorithms are producing the very less accuracy, and the time consuming, so that we can move for the unsupervised learning algorithm. The unsupervised learning algorithms, it is usually takes a very large amount of data, and it processes the data over the time, and it produces the optimal result. So we have discussed about that the various deep learning algorithm. We have seen that there is a set of deep learning algorithms like RNN and recurrent neural network are these algorithms are insufficient. So most commonly we have to use that unsupervised learning algorithms like a GAN-based generative model or the reinforcement model. The reinforcement model, it mostly uses the agent-based learning. And based on this, the combination of that CNN with the new idea of the algorithms, it gives the federated and the new deep learning algorithms. So these are the models. So newly in the any new research in the future, it is recommended by using that reinforcement learning or hybrid models of combining the several deep learning architectures already existed. Also by using the unsupervised learning algorithm, so that we will get that more accurate result. And advantages and limitations of this supervised learning algorithm already we have described. So it is heavily dependent on the large labeled data set. Processing the labeled data set, converting the raw data into labeled data is the time-consuming process. So that it is important we move into the unsupervised learning data. So unsupervised learning data, it uses the unlabeled data, and the models we use in the deep learning neural autoencoders, restricted Boltzmann machines, RBM algorithm, deep belief network, generative adversarial networks. These are the unsupervised machine learning. These algorithms are recommended for doing the research. So autoencoder, it uses the raw data and compress the data and also it reconstruct the data, so that it find the variations. So that during the compression process, the autoencoder deep learning networks to find the useful patterns, and also it removes that unwanted noise information. And the decoder network, decoder neural network, it to find the encoding of useful information. If any deviation in that or deviation of the semantic of information, then it can that propagate and performing that mapping to the original data. The major challenges in that autoencoder architectures, the vanishing the gradient is the problem, and hyperparameter tuning. These are the two problems. Hyperparameter means when it is encoding the unwanted information or sensitive information is removed, then it should be adjusted. For that, it has to take the very long time to readjust again. And RBM, it can be used for the probability reasoning. And it performing that future extraction by using the limited number of binary constraints. So already these generative autoencoders already discussed. Deep reinforcement learning. Deep reinforcement learning, one of the important algorithms in the current research of the deep learning. In this deep learning algorithms, the agent interact with the environment and it gets some input value, and it process it test that input value. It is called the trial method. Sorry, it train the input value by that is trial. Then it test. Then if it is error, then it again adjust that values in that every node of the neural networks. So the major objective of this deep reinforcement learning algorithm, it want to maximize that reward, and it also models by using the markov decision process. Deep reinforcement learning, its advantage, it can able to handle the high dimensional input spaces and enable that autonomous decision making. Also, it explore that real-time adaptive learning. So it can be most useful for the real-time environments because it is the agent-based. The major problem in this, it requires that very large computation resources. Also, it is recommended in the deep learning research is the hybrid deep learning models. The hybrid deep learning models means it can combine that the very familiar and most optimal deep learning algorithm. It is added to the other advanced algorithm. For example, CNN plus LSTM, and it can be used for facial and the temporal learning. Actually, LSTM it can be used for adversarial neural network and to avoid that gradient error. Okay. Similarly, we use that CNN with autoencoders. So the familiar algorithm is combined with the other familiar algorithm. It gives that more optimal research, and also it improves the performance in the way of handling the multidimensional data. So online learning strategy also nowadays improving in the research area. So online learning means so the deep learning model, it will learn continuously adapting the streaming data, like live image or live video like that. Mainly it is used for IoT devices sensing the information, or you want to find that so you want to do the cyber security, detection of the cyber crime. In this areas, we require some research that can be improved by using these learning strategies. And the learning strategies mainly it is based on the memory mechanism. Major challenge in this area is the high computational overhead, catastrophic forgetting, and difficult optimization, dynamics environment. Transfer learning also one of the important research area nowadays. We transfer that information one transformation, one stage into the another stage over the networked set of computations. So the major benefit of the computer is reduce the labeled data requirement and improve the convergence speed. Also, it improves the performance. These are the different types. Instance-based, it calculates the reweights of sample and also minimize the domain discrepancies. Future representation TL, it learn the shared talent representations. So talent representations, it find that the data, it is processed in that one representation transfer into the another representation. Federated learning, also the one of the important research in this deep learning. Federated learning, it scaling, it performing the different types of deep learning algorithms combined in that different way, so that it can be able to produce that very optimal result. There are two types majorly in the federated learning: horizontal federated learning and vertical federated learning. Horizontal federated learning, it uses the same features and a different sample. Vertical federated learning, it uses the same samples and different features. The challenges in the deep learning is data issues. We have to collect the data, and we want to get the more accurate value. We should have the large data. And also, second important challenge is the ethical and fairness challenges. So we have to use the data. The data is every data is the valuable one. And also the information in the data should not lost, so that when you are processing the data, we have to bias that algorithms. Then model interoperability, because our hidden layers are working as that black box model. So whenever we are designing that machine deep learning algorithms, we have to keep secure under the trusted manner, so that we the information, because the secure data is processed deep learning algorithm, so information cannot lose, or it can be dissipated to that the other intruders. So other thing is adversarial vulnerability. So decision boundaries we have to set. So another research issue is the safe and reliable learning, because that is anytime the unpredictable behavior in the real world environment, it can be like for example stock market prediction. We use the deep learning algorithm. Data is very important. Okay, so it is changing the data, or unwantedly something it will be happen. Then the learning it is very difficult. And the heteroscopic flattening, the information is transferred into that one input hidden layer to another internal layer. It should be performed in that without changing the semantic of the data. Domain adaptability is another important challenge, and it should be used for the future transformation. So these are the suggestions for the new research development of the data efficient learning technique, like semi-supervised learning, meta learning, and the few sort of combinations of the unsupervised learning with the reinforcement learning. And also the research should be in the robust and the interoperable deep learning models with explainability layers. Also, it is recommended improvement of the continual learning frameworks to prevent the catastrophic forgetting. Advanced federated learning protocols, it provides the secure aggregation and different privacy of the data. In hybrid architectures, it is recommended. Also, it is recommended automated machine learning. So nowadays, this auto ML is progressing to optimize the architecture by adjusting the hyperparameters. These are the research. So participants, if you have any queries, please ask.
Participants are welcome to share their questions in the Zoom chat box, or you can also unmute and speak. So there is one question in the chat box, sir.
Yes, sir.
If a model accuracy is 1, is it acceptable or not? Will it be considered as overfitting?
Overfitting data is there, then the deep learning algorithms, it is struggle to process the data. So that we have to make the data should come in the range. Then only it is able to process. Any deep learning algorithm, it try to avoid that overfitting. If there is a overfitting is there, it automatically adjusts the data. So data can be adjusted. So the hidden layers of the deep learning, it always try to adjust the weight and that input data using by applying that bias function, so that any overfitting and underfitting are there, that also adjusted. So deep learning most commonly all deep learning algorithms it do it automatically.
So any practical use case is the next question, sir.
So there are the practical use case means we have the different, we have analyzed today's session, the different deep learning algorithms. CNN algorithm, it can be used for the medical image processing, cancer, brain tumor detection, cancer detection, it can be used for. The classification, we can use the AN and simple AN algorithms, it can use for the classification. For example, we have that new billions number of images are there. It can be given as the input. We identify the what kind of image, what is the pattern is available, pattern recognition. It can be performed using that AN algorithm. Then other algorithms like adversarial learning algorithms, it can be used to generate that converting the fact images into the real images. There are the depending upon that problem, we can take that the corresponding deep learning algorithm. We have the several data set, and it is the nowadays the advantage is we have that numerous collection of data set which is available in Google or other websites. We can use the data set, and using the data set we can use the what is the algorithm is suitable. We can identify it and we use that particular deep learning algorithm. And the deep learning, it provides the very diversity and the high dimensional of research on these days, compared with that IoT and the cybersecurity, blockchain, like that.
Hope no more questions, sir. Thank you very much, Dr. Arul, sir, for sharing your expertise with such clarity and depth. Your session has truly enhanced our understanding. To formally express our gratitude to everyone who contributed to making this section meaningful, I invite Mr. M. Anis Ahmed, Assistant Professor, to deliver the vote of thanks. Kindly take over, sir.
Yes, sir.
Yes, sir. Thank you, sir. Good evening to everyone. It's my privilege to deliver the vote of thanks on this wonderful occasion of the Faculty Development Program on behalf of organizing committee. First and foremost, I express my sincere gratitude to our management committee members, our chairman, Mr. Imtiaz Basha, our secretary, Mr. Nazam Mohammed, our treasurer, Mr. S.M. SMA Muhammad Salim, and the entire institution for providing the foundation and support that enabled that initiative to thrive. I extend my heartfelt thanks to all who have contributed to the success of this program. My deep appreciation goes to our esteemed resource person, Dr. Arul from the Department of Applied Machine Learning, Institute of Computer Science and Engineering, Savita Institute of Medical and Technical Science, Chennai, for taking time from his busy schedule to share his valuable insights and expertise on topic unlocking the research potential of deep learning algorithm. Your thought-provoking lecture and practical section have enriched our knowledge and inspired us to enhance our academic and professional pursuits. We are truly grateful to our director, Dr. M. Usha, for her constant encouragement, guidance, and support throughout organization of this program. Your leadership continues to motivate us to strive for excellence. A special thanks to our HOD, Dr. M.D. Vimalapriya, for her unwavering support, motivation, and leadership. We are sincerely grateful to your vision and guidance. My sincere appreciation also goes to the organization committee and all our department faculty members for their dedication, coordination, and behind the scene efforts that ensure the smooth conduct of our every session. I warm thank you all the participants for your active involvement, enthusiasm, and meaningful interactions which have truly enriched this program. We also have acknowledged the efforts of our technical team and support staffs for ensuring seamless and efficient experience throughout the event. Lastly, I extended my gratitude to everyone who has directly or indirectly contributed to this program. Your support has been invaluable. Thank you, one and all. We look forward to meeting you again in future academic endeavors. Have a wonderful day. Thank you. Thank you so much, sir. Over to you, sir.
Thank you for the thoughtful wonders of appreciation. With this, we conclude today's day 4 session of the International FDP. We thank the resource person, participants, and organizing team for the dedicated involvement. Wishing everyone a productive and pleasant day ahead. Thank you and see you in the next session. So thank you, Arul sir. Participants, the feedback and attendance link has been shared in Zoom and YouTube chat box. Kindly fill it out.
Thank you very much to the participants, and also I would like to show my sincere gratitude to the organizers of the 5 days development program, and also the director madam and HOD of the department, the management. Thank you, sir.
Thank you, sir.
Thank you. Thank you so much, sir.
Participants, once again repeating you. The feedback and attendance link has been shared in the chat box. Kindly fill it out. Afsal sir, wait for 2 more minutes, sir.
Oh, okay, sir.
Okay, sir. Still, sir, share one more time in the YouTube chat box, sir. Afzal, sir.
Done, sir. Done, sir.
Okay, sir. Okay, sir. Thank you, sir.
Shall we end, Sabri, sir?
1 more minute, sir. Sir, quit, sir.
Okay, sir. Okay.